Hello, everyone. Thank you all for joining me here on this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Missie Smith, who is a research scientist with a great experience in both industry and academia. Her research interest in the past, at least, has been in AR displays and HCI, and has done a lot of research since 2015. The title of her talk is Designing Novel Technology, a case study in augmented reality for drivers. The talk will be roughly an hour, followed by a brief questions and answers. Thank you all, and welcome, Missy.
Well, thank you. Thanks, Aladdin, for inviting me and following up. I know it took many months for me to reliably respond, so I appreciate your patience. And that was a great introduction. I won't add much, although I did check the policy, and I can say that I work at Meta. And generally, I'm working in the Reality Labs research group, and so there's a lot of different research that's happening in that space. And my space is generally around just how people interact with augmented and virtual reality. And so I put 2 dates on there because I know we're in multiple days, but that's about all that's interesting on the first slide. So I think a good place to start with anything is just to know kind of where people are coming from. And I think that's something that being in engineering for all of my degrees, I didn't appreciate the fact that like people coming from diverse backgrounds would have such different approaches and opinions. And so that's one thing I've gained an appreciation for, certainly while being at Meta, and kind of making that transition from academia to industry. Because I feel like in academia, it's a little easier to kind of insulate yourself with people that have the same opinion and get their validation. But anyway, so to give you an idea of some of the biases that I might have and what has shaped my research to date, I have 3 degrees, all in either industrial and systems engineering. And so even though by some standards I have been a UX researcher and that's viewed as, less technical, I actually do have that engineering core background. And there's 4 main areas of industrial engineering. So there's manufacturing, ergonomics, supply chain, and then engineering management, which is basically managing engineers, if you didn't guess that. So I have a little experience with that now, but early in my career, I kind of cycled through those big 3. So my freshman year, my first year in university at Mississippi State, I started doing undergraduate research and focused with a professor on things like comfort and fatigue and understanding ergonomics, primarily in the workplace, but also kind of looking at novice versus experts. I also got an internship. I spent a year working in manufacturing at a company called Eaton Aerospace. And then after I got my master's, I moved to supply chain, and I actually worked at a paper company, which I thought would be, I thought it was, very uninteresting and also very unimportant. But when we had that toilet paper crisis early in COVID, I gained a new respect for how much pressure they put on us with supply chain of paper products, because they are important. I have at least learned that lesson. But I quickly learned I don't love supply chain. And so I started to kind of seek out other opportunities. And that's when I went to get my PhD at Virginia Tech. And while at Virginia Tech, I started to focus on augmented reality and head-up displays, particularly in the context of driving. So I spent a couple summers at the University of Nottingham. I also did some work with Jaguar Land Rover. And then I also did an internship at Ford Motor Company. So I have kind of a strong driving background, but also all of that was pretty heavily tied to augmented reality and head-up displays. And that's what I'm going to primarily talk about today. After I got my PhD, I was a professor for 2 years, and I was a professor of industrial and systems engineering at Oakland University, which is in Michigan. And then I was one of those people, I made that mid-pandemic switch to industry. So pretty early on, August of 2020, I realized that the kind of research I wanted to do, I could do it better elsewhere. And so I wanted to explore the potential of doing kind of the best augmented reality research that I possibly could. And I knew that that would need to be at a place like Meta. And so that's how I wound up there. and where I still am. So I've been there about 2 years, which is, if you followed all of that, actually the longest that I've had a job. So that's pretty interesting to kind of reflect on that, because that's a bit of a surprise to think through. So all of these have shaped kind of my approach to research, the type of research that I do, and how I think about the space. And so we'll just kind of dive into it. But I always think it's a good, I called this talk Designing Novel Technology. I think it's a good place to start with just like, what are we talking about? So what technology do I mean? What are the novel technologies that I focus on that I'm interested in? And I know Rick is on this call, so some of this will look very familiar to him, because I'll start with reality. Everything is real. We also have, as all of y'all know, virtual reality, which means everything is virtual, and then everything in between. And so in partnership with Rick and Mary Whitten, we've spent a lot of time talking about this space, and we came to the conclusion that we are all of there. So we're kind of across that. And if you look really closely, I was very particular because we can study reality. We have reality that is achievable. But that bracket does not overlap with virtual reality, because we believe that virtual reality actually has to completely override the senses. You have to provide virtual information to everything for everything to be virtual. And so this is why I have come to the conclusion, I think that it should be mixed reality, because we're actually mixing our senses. So we have some information that is coming from the physical world and some information that's coming from the digital world. And so without actually like directly overriding the brain, which is like the Matrix, which if you've seen that, you may realize it may not be the best option, at least right now, or at least if there's evil robots, or artificial intelligence, I guess. But either way, we don't yet have that capability. We don't know if we even want that capability. So for all intents and purposes, all of the realities that we're talking about are in some way mixed, unless it's purely real. And I guess another thing I'll point out is that also my perspectives on this space have gotten pretty liberal, in that like what I think it takes to make something not purely real is not very much. So that's a whole deep dive that we could have about, what is technology and what is digital, and at what point is it does it change from being just reality to being some type of mixed reality? But we won't go down that rabbit hole. But also I will say that this was a really fun paper to write. It's also now my most highly cited paper. But if you're interested, I think it's also important to note that, having those think pieces where you're digging into frameworks is really important. And also I wrote on Twitter about kind of how that collaboration came to be and what I learned from it. So if you're interested, I can share that link. But I think it's important to be thinking about this and trying to understand, like, what is the space that we're working in and what does that mean? And so kind of moving forward, we can use the same structure to think about how we define that technology. And so that continuum that I just showed you was based off of, as it says, Milgram and Kishino's reality virtuality continuum. So we revisited that. And what we found in the paper is that they also had this taxonomy for describing, everything that's on anywhere on that continuum, but people don't often refer to it as much. And so what ended up happening is we kind of accidentally realized that we wanted to update this. And so the bulk of what we did in writing this paper was basically deconstruct that taxonomy and then try to figure out, like, how can we update it for the technology that we have now, because it had a really heavy focus on graphics, for example. But we're also doing a lot of, multimodal work. We have people that are studying smell and taste in addition to kind of the traditional graphics and auditory, and haptics, I guess, is kind of in the middle. So what we wound up doing was basically revisiting this, and we found they had a continuum for extent of world knowledge, which is basically the system knows nothing to the system knows everything. And I realize I think I put this backwards, but oh well. Details. But anyways, in that continuum, this was actually straight from the original continuum, because it still holds true. Like, we still have that is still a key piece of the information that we need to know about a system to define what the technology is capable of, so that we can then use that definition to help guide our research. The second kind of continuum that we added to the taxonomy was a blend of two of theirs, which is immersion. And it's basically saying you can go from having no virtual content to having content that can support the user actions. And it basically enables people to interact with the system. And that also includes things like having better displays and using multiple senses, because now we're enabling more types of interaction. So it's like going from I'm looking at something or just seeing or just hearing something to being able to do more with it. So that's increasing immersion from nothing to every possible action. And then the third continuum is coherence. And so that's going from no virtual content to something that is basically where every behavior is plausible. And so everything, and so kind of pushing it towards where we can make it believable. I mean, it's really going towards plausibility illusion, basically, for the people that are using it. And so this is kind of, I think, a very useful way to define the technology, because if you use these three continuums, you can pretty well articulate and describe the technologies that exist today. I do think there's, a whole line of research, for example, with like immersion, where you could also consider that for individual modalities. So I'm not saying that this is like the end all be all or enough detail to kind of answer every question, but it's a good starting point. One thing that I've gotten really kind of in recent months, I've gotten really fixated on this concept of fractals, because I feel like this, you parameterize the space, you identify a framework for which a way to think about it. And then as you dig into each individual component of that framework, there's like another equally complex framework that needs to fit beneath it. And I feel like this is probably a good candidate for one of those. But I also think that this can be really useful. So, I talk about how we're defining the technology itself. I also think we could use this kind of framework. Oh, my slides won't advance. Okay. To speak to what kinds of problems we're solving. So now thinking about this from a different way, that extensive world knowledge is really about like people are trying to solve the sensing problems that we have. What's happening in the world? How do we know that? How do we track that? There's even like enabling technologies for that, decoding technologies, a lot of sensor development, miniaturization of sensors. Like there's a whole body of work just in kind of working on this individual continuum. For immersion, I mentioned it's the interactions enabled by the system. And so this is where there's, there is some hardware development. There's also a lot of human factors research that can happen there, of just trying to understand what feels right and making sure that we are improving the displays in the ways that are needed for people, and kind of having that, like, how do we provide the immersion that's needed, or what's causing it to not be as immersive. And so I think there's a lot of work there that kind of is a hybrid between hardware development and what I would call human factors or human computer interaction, or even UX research, depending on how you define those things. But I think I highlighted it because that's where I think a lot of my work falls. But I won't say 100%. I also do a pretty good bit of work in the coherence space. And so to me, that space is kind of, figuring out what's the right question. So, there is that like plausibility component, but also it's like, are we looking for believability? Are we looking for learning a specific skill where maybe the entire experience doesn't need to be believable, but we need this particular skill set development to be coherent so that people are learning the right thing. So I think there's a lot of work in that space, and it tends to be a little more, in my opinion, end user focused and almost like big picture. What's the goal that you have with that technology? So anyways, this is obviously a fun thing. I enjoyed working on this paper and thinking about this space, and it has really shaped the way I think about the work that I do and kind of how I think about what needs to be done, because I don't think that any one of these individually is what needs to be done. I think we need a blend of all of them, but it's helpful to know kind of where I think my expertise is and where I think I can provide the most value. So So yeah, kind of going back to now this continuum, I mentioned, okay, well, what technology? Well, there's this whole continuum. And because of that taxonomy, like wherever it falls on the continuum is also, there can be drastically different implications of, the extent of world knowledge and how it all fits together. So just for the sake of kind of being concise, I will say that primarily I am interested in technology that falls on the left side of the continuum. So I don't want everything to be real, but I do want most of it to be real. And I think that's just because those are the kinds of questions that I find really interesting. But I think there's different questions depending on where you land on the continuum. And I also think that there's different kind of benefits of everywhere on the continuum. So I have kind of come to the conclusion that I think that different places mean different types of research, because you might need to then work on more sensing technology, or you might need to work on more, hardware miniaturization. I don't know. But I will also say, so earlier I said mixed reality is the term I think you should use, but I will recognize my limitations and say that I will probably say augmented reality throughout this presentation as a shorthand, because it is easier to say that than to say mixed reality, but with primarily real and some digital. So I'm not going to, categorize it that way every time. And also, I've just said it so many times that even if I tried not to, I think I would still say it. So I'm intending this point on the continuum roughly when I say augmented reality. So I wanted to, I guess, kind of take that and say, put it a little more towards like, how do I approach research and what does that all mean? Because I think it's useful to have that kind of framework to think about the big space and to understand where your work falls and also how it kind of connects to other work that's being done, because they are related. And I think that we would all agree that, we can, on the more augmented reality side of things, we can learn stuff from virtual reality, but we can't like copy and paste it. We need to be really selective in what we pull from other places on the continuum. And so I think that's really helpful to know. But, practically speaking, how do we design a technology that doesn't exist? And so this is not the only way to do it. It is the way that I have tended to do it. And so I think there's at least some value in doing that. And so I think the first step in that is to start with the problem that the technology should solve. And so just to kind of focus in even a little more, I mentioned augmented reality for drivers. And so what's that problem? Like what's problem are we solving by having augmented reality for drivers? I think that's one where clearly it's not just like enjoyment. It's not just something that people prefer, but it all goes back to distracted driving. And so this is US statistics. So apologies, that is not very global, but they were easier to obtain. And so in the US in 2015, also a little dated, but the trend is generally up. So we could expect that it's probably higher than these numbers. So in 2015, that's 7 years ago, we had almost 3,500 deaths and 391,000 injuries from distracted driving. So that's what the cause of the accident. And the really sad thing about this is that there's a lot of other reasons that people get in car accidents, but this is a preventable reason. And so in theory, if we could solve distracted driving, this is 3,477 people that are alive, and that's 391,000 fewer injuries. So there's huge implications of actually solving that problem. And we know that distracted driving, there's cognitive distraction, which is kind of taking your mind off of driving, manual distraction, which is taking your hands off the wheel, and visual distraction, which is taking your eyes off the road. So we know that distracted driving is a problem. There's multiple types of driving or distraction that can cause this. But we also know that visual distraction is at least believed to be kind of a key piece to that. And so that's because there's a lot of different estimates, but a kind of good rule of thumb is that 90% of necessary driving information comes through visual channels. And so visual distraction is a huge issue. And also we've seen that a lot. So there's a really famous study called the 100 car study. It occurred in the early 2000s at Virginia Tech Transportation Institute. And basically what they found is that off-road visual attention was linked to a higher risk of crash risk. or a higher risk of crashing. And so basically eyes off the road correlated very strongly with more likelihood of accidents. And they also identified this threshold where a 2-second glance, so anything longer than 2 seconds away from the road, was also associated with a higher crash risk. So we're seeing really strong cues that like confirm, maybe not that 90% rule, but that visual distraction is a problem. And so that's kind of the background of why there's a problem to solve. It's clear that there are some issues. And there's been a large body of research focusing on AR HUDs, or augmented reality head-up displays, to fix the problem. And so I'll define augmented reality head-up displays. I use augmented reality loosely, just to mean an optical see-through display. But there's also, going back to my initial start, like there's a lot of different types of augmented reality potentially, because you could have screen or video-based augmented reality. But for the sake of driving, I'm talking about optical see-through displays. And then a head-up display, we could kind of think of, if you imagine a car, and it may be on the wrong side of the road for most of y'all, so apologies for that, but it was hard to change my graphics. But you have a head-down display. So this would be like your radio inside of your car. It's kind of down below the steering wheel, or to the left or right of the steering wheel, depending on what kind of car you're driving. While a head-up display could be projected or displayed somehow onto a windshield. And so it's actually in front of you, it's overlapping with the road. And so in theory, you should be able to see roadway hazards while you're looking at the display. And so, I mentioned, what problem does it solve? What is the goal of the work? Because that's a good starting point to try to understand how we design this technology. And so there's a lot of work in this space. And so I'm not going to go into super much into the weeds there. But really what we found is, there's research suggesting that head-up displays results in more time with the eyes on the road, which we think is a good thing, faster reactions to the road. So they're responding to hazards more quickly, decreased mental workload. So it's easier to do what they need to do. They're actually, expending less mental energy to try to do what they need. And improve vehicle control, which is basically, are you staying in your lane, and are you also maintaining a safe distance from cars around you, specifically ahead of you? So that's kind of like, that's really good. That's positive, good news. But then we also kind of, because we're starting with like this problem-oriented piece, we also need to think about what problems do AR HUDs create. And so there's kind of, for each one of these, there's almost equal but opposite. So now we also have found that there's longer display glances. So people actually look at the display for a longer time, even though they're able to keep their eyes on the road for longer. There's also evidence showing that people ignore hazards. So they maybe respond faster, but they also ignore some. So it's like, that's good because you can respond more quickly, but also you miss some. And hopefully the ones that you miss don't matter. There's also evidence of increased mental workload and driving task decrement, so actually being a worse driver. So kind of what my point with this is that, it's a new technology. We've got a lot of positives, and we think that there's a reason and value in doing this work and trying to make this technology a possibility. But we also see that it doesn't solve all the problems, and it may even introduce new problems. So it's not just like, let's just insert it into cars, but now we have to really deeply understand it. And so the whole point of this is that just recognizing that it's a complex space. And I personally believe that most technology that we can provide now, most of the things that we're creating, I don't think that anything is going to really solve any problem, because I think there's always kind of these subtle ripple effects where it introduces some new either problems or variation. And we just need to make sure that we understand that, so we design it appropriately, because we don't want to only look at the good side and then ignore the bad. And so I said, the first thing is start with the problem the technology should solve. And I think that's to show, like, does it show evidence that it does actually solve some of the problem? And then also, is there evidence that it introduces new problems or that it doesn't solve the problem? And so I think that's kind of where we fall with augmented reality for drivers. And so I think kind of a next step for that then is, you could try to figure out every possible use case. There's a lot of ways to approach it, but I think for me, what makes sense is to parameterize the design space into something that's kind of tractable. So we actually can start to test qualities of the system rather than like independent iterations of the system. And so that's kind of where I went to next, is how do we parameterize the design space of augmented reality in vehicles? And so again, we have this imaginary windshield. We can kind of consider one way of parameterizing is the location. And so most original automotive manufacturers right now put their, if they have a head-up display, they put it on the windshield, but just right near the dashboard. And so it's really low, it's kind of overlaid on the hood of the car and really near to you in the road as a driver. A second location, and this is shown, kind of some other research has shown that this is probably the most promising location for some problems that we're trying to solve with attention and driving. And that would be to just directly overlay it onto the road so that it's right in front of the driver while they're driving. Another location is to put it kind of above hazards. And so this would be a lot of like aftermarket head-up displays that you could buy. They tend to be something that you would attach to the top of your car, like where your sun visor would go. So we have not only like 3 distinct locations, but also different rationales for each of those locations, which I think is a good way to parameterize the space. But I will point out that, you know, this is continuous, right? Like it could be halfway between any of these or a quarter of the way between them. So the goal of parameterizing is not to consider every possibility, but I think it's to really try to understand, like, are we investing in the right question? And I think that's where, like, because for something that's so early that doesn't exist, it's also very difficult to research. We want to make sure that we're investing our efforts in the right space and working on problems that matter. And so if there's no difference between these 3 locations, that's wonderful. That means that we can move on to other issues and try to figure it out. But so anyways, this is where, for some of the work I did, I started trying to consider, how does the head-up display location affect driver glance and driving behaviors? And so the reason for that is because I mentioned, you know, glance behaviors are incredibly important. That's something that is standard across driving research. There's a lot of emphasis on it, but also driving behaviors give us a direct measure of, like, how are they performing? Are they doing a good job? Because maybe glance behaviors and driving behaviors aren't as closely coupled when it comes to head-up displays as we have traditionally thought for driving displays more generally. Maybe that's an artifact of the type of display that we had. So I won't go into all of the details of the study. I believe we had 20 participants, half male, half female, all kind of within the same age range, because there are actually age differences in how people drive as well. So we wanted kind of a compressed, like, here's a deep dive into one age. And we had them do a series of tasks in a driving simulator. So we actually had a separate overlay, which was the AR graphic. So it was AR and VR, but it was 2 separate displays. And I do think that's actually important. But I don't have a lot of research on that. That's just a theory. But anyway, so they were doing a driving task. And so they had a primary task, which was car following, and it's really small, but this little white dot here is a car ahead of them. So I think I was taking a picture while while trying to drive so that I could, which you should not do in the real world, but it's okay in a simulator. So it was a little far away from what we would typically want, but they were told your primary task is to drive safely, to follow this lead car, because you need to, they're helping you navigate. You need to go wherever they're going. So that was their primary task, which is a reasonable, you know, that could happen in the real world. You might follow a friend to a party. And then we had them do 2 different task types. And so these tasks were designed to be difficult enough to cause an impact on driving. So we actually did want to see if there were differences. So these are not tasks that you should do while driving, but also the first one is a text task. And so they basically had to search for a target letter within a set of kind of non-real text. And it was based off of, not entirely, we made some adjustments, but it was based off of an ISO search task called pseudo text search. So it causes similar glance behaviors as what you would do while reading text, but it takes away like the meaning, it takes away the semantics. And so what it does is kind of levels the playing field so that somebody that has like specific emotional reactions or different reading levels, they're less affected. So we get a more clear picture of what's actually happening as a result of the task and the driving and the things that we care about, not the, the words that are on the screen. The second task was also a search task, and they were searching for a symbol. So these are all driving symbols. And so we had them search for one that would be an important symbol, the warning signal, which would be important while you're driving to be able to see. And so we wanted to have it be kind of realistic, but also, something that we could make some reasonable comparisons about. So we considered those 3 different display locations. So low being right above the dashboard, middle being in the middle as if it's overlaid on the road, and then high being kind of where your sun visor would be up in the sky. We counterbalanced the order for that. And within a single drive, they experienced 2 different task types. So they experienced each of the tasks. We also counterbalanced that, and we had 15 repetitions. So this is kind of just the experimental design. And so moving to results, so the first question was, how does the location impact drivers' glance behaviors? And I should have spaced this a little differently. So I know it's a lot of graphs at one time. So I'll just walk from left to right. So what we did was we used 3 different measures of visual attention that are commonly used in driving assessments. And so the first one is the maximum duration. And so this is the longest that people were willing to voluntarily in seconds look at a display. And so these were really visually demanding tasks. And the first thing to notice is that for all of them, I mentioned earlier that 2 seconds with your eyes fixated away from the road is deemed like critically dangerous. And all of these were very much over 2 seconds. So the average was actually, the lowest was 11 seconds. The highest with the HUD middle location was 14.2. And so the high location and the middle location were statistically significantly different. And so it kind of shows like people are really looking at the display, especially when it's like right overlaid ahead of them. And we could talk through, that's not hugely surprising. I think the question is that a problem? So we also looked at the percentage of time that they looked at a display. And so this is, looking at the display versus the road. And so again, we see that the HUD middle, it was the highest percentage of time, but now the low position actually is performed the best or performed better, statistically better than the middle position. So we're kind of seeing some differences. And then we also looked at the percentage of long glances. And so a long glance is anything over 2 seconds. And so basically most of their glances were longer than 2 seconds, which with a normal display is a huge concern. But now we see that the worst one was the high. And so it's kind of all over the place. So there's not like something really clear, but I do think that it's important to note they did spend really long glances. So their maximum duration was towards the display, and then also the highest percentage of time towards the middle. And so there's some evidence that this middle location may draw more visual attention. So even though there's evidence that it's a good thing from prior research, we also now it's kind of like, well, we should be at least cautious about this because we really need to understand like, is that different now that we have glances on the road? And so regardless, we do have a pretty mixed response. So about driving behaviors, that was the second question. And so I mentioned earlier really briefly, but first is lateral variation. And so this is position in the lane. So basically you're making micro adjustments so that you stay relatively centered in the lane. And so the more micro adjustments or macro adjustments, if you're actually swerving out of the lane, the higher the variation. And so better driving is associated with lower variation. And so we see that the low display, the one right above the dashboard, is actually the best performance because it had the least variation and lateral variation. We also considered longitudinal variation, which is the lead car ahead of you. What was the distance? And we measure this in terms of time headway. So basically like you're driving, so you cover a certain distance in a certain amount of time. So how long is it before you are likely to, how long if they stopped immediately before you hit that car? That's what time headway is. And in this one, we see the opposite. So we actually see that the high display resulted in the least variation. So they were the most steady and they weren't constantly speeding up and slowing down to adjust. So again, now we're seeing that it's inconclusive, it's kind of mixed results, but at least there's a different impact. Like HUD location may impact them differently, and that's probably worth noting. And I think really kind of the takeaway from that, and the takeaway from all of this, is that like we have really mixed results and we think it helps, but like that doesn't answer the core question. And so going back to kind of my process, we're parameterizing the design space, but it doesn't tell us what to do yet. We might have some new hypotheses. And so the hypotheses that you would take and run with might be different. But regardless, I think the next thing is just do it again. Basically, like take what you learned from that and figure out how can we better parameterize it, or do we need to do a deep dive here? And so for dissertation and resource constraint purposes, I didn't deep dive on those particular things, but I think that you could do that. But I think the important thing is just figuring out, what's next? What is the next piece that we need to consider? And so moving forward, what I chose to think about and dive into is that I think that we can do a better job of parameterizing the space. I'd spent some time, doing research. I've been thinking about it a lot. And so I realized that we had talked about location on the windshield, but I actually think that spatial location and considering, whether it's relative to the screen or relative to the world is another important thing to consider. And these are not totally distinct things, because depending on if it's relative to the world, it might influence where on the screen it occurs, but maybe this would give us clearer signal or a better way of understanding kind of what's happening. And so, we have things that are screen relative. So what that means, just to kind of be clear, is that you have something that's on the screen and tied to the screen, like that text that I had. That would be screen relative graphics. You could also have world relative graphics, and you could portray the same information in either way. So it doesn't mean that like we have a lot of flexibility. So we can portray the same information in many different ways using spatial location. We can also use motion. So we could have the same information portrayed via motion rather than just using screen or world relative. So these were both fixed, but you could also animate them. And so a way that we could animate that is, for example, having the arrow move. And so have some sort of motion that's giving the information that we want to convey. And this is not a great animation, but easy to do in PowerPoint, and one that I wouldn't recommend for navigation purposes. But just an example of something that, what I mean by animated but screen fixed. Or animated but screen relative. It stays on the screen, it's relative to the screen, but it moves. Similarly, we could have the same for world relative. So we could actually have something that's moving in the world. And I don't have a neat graphic for this, but I also want to point out, I think there's a third parameter that I didn't dive into with this work, which is the information visualization. And what that means is that you could actually consider whether the information is 2D or 3D. And I think that there's a lot of rich research to be done there as well, because I'm unconvinced that most 3D graphic use cases are actually worth the effort, worth the computational load, and worth the processing that people have to do to kind of rectify what they're seeing. But somebody could prove me wrong, and I would love to see a lot of work in that space. But there hasn't been as much that's kind of systematic and considering these different categories that we might want to consider. And so this is a reference to the paper that I wrote, but didn't dive into the visualization as much as it did into the spatial location and motion in particular. And so for this, you can imagine, again, here's our windshield. And so it's basically considering how does HUD graphic type, whether it's screen or world, fixed or relative, how does that affect driver glance behaviors, driving behaviors, and task performance? And so again, it was the same, laboratory setup. So we had that medium fidelity driving simulator. So none of that changed. And I think we had 20 participants, maybe it was 18, but either way, a similar kind of setup. But for the experimental design, one thing to note is that we did not have a screen animated graphic, and that was just based on, we partnered with an industry partner, and they required that these were the graphic types that we used. We also didn't see a ton of benefit for this application and having something that's screen animated. So it was kind of okay that we didn't have it, but I did want to point that out up front. We have 4 conditions, but we have 2 that are world animated. And those 2 graphics were basically a digital car that you could follow. So we still had a car following task, but now the car was digital and it was the navigation aid. So it was as if you were following this virtual car. So each participant saw all of those within a single drive. They had both left and right turns, and they also experienced that with and without traffic. And so we just wanted to give a mix of driving, kind of realistic things that you might encounter, so that we could get a little maybe richer signal on how people were responding to these navigation instructions. And so another thing that I think is important to note, and it'll kind of explain the data that I have, is that for the analysis, traditionally, we would say like, oh, they're looking at the display or the road, and we would compare those 2 things. But now we have, again, this merging of the display and the road, and that can be difficult because it's not necessarily clear, if they're looking at the display, is the display on? Is there a graphic on there, or are they just looking through the display and actually they're focusing on the road? So to kind of work our way around this, we had a more complex analysis scheme. So we actually identified like where specifically within individual images was the graphic. And then we categorized those glances where they were looking at the graphic specifically as a HUD graphic glance. We also had around the HUD graphic, so anywhere that they were focused, like right around the graphic, is kind of this buffer where they could have been looking at the graphic, they could have been looking around, at the road or at other hazards, but it was really unclear. So we did kind of keep a little buffer just to not skew the data based on like what it looked like if it wasn't totally accurate, because there are some issues with eye tracking, especially when it's a little easier when you're eye tracking into a virtual world than in a real world. So and also the display made it extra tricky because you also had to be at the right angle to catch the display. And so that made it a little more complex. So we wanted to have a little buffer just to be sure we weren't confounding anything. We also considered on-HUD hazards specifically because those, first of all, could be a different category of hazard. So they might be things like it's more likely to be a car slamming on the brakes or something that's up in front of you, which is distinct from off-HUD hazards. And so that could be things in your rear view mirror or other mirrors, pedestrians walking on the sidewalk, stuff like that. So we wanted to keep those distinct because they're probably different types of hazards, at least for this display. And also because, that data would have been lost if we did a traditional analysis. And so we wanted to make sure that we were considering kind of, is that giving us more information? So moving into the results for this, so we tested by basically ordering, so screen fixed, my argument is that it's the least integrated into the world. It's the most digital feeling because it's totally distinct, doesn't have motion. World fixed graphics are more integrated into the world because they're kind of overlaid onto the world, but they don't have like real world behavior. So it's not feeling like a part of the world necessarily. It's kind of like an annotation. And so then when we had these 2 different types of animated lead car, that's a different type of, it's kind of almost like we're moving towards more realistic in quotes because they're now behaving like objects in the world. So I believe, integration may not be quite the right word, but it's kind of moving down towards more and more realistic. And also we distinguish between the 2 animations because they had distinctly different driving behaviors. So one driving behavior was a little more natural. And so that's how we decided which was World Augmented 1 or World Animated 1 and World Animated 2. So the actual behavior was more realistic going from left to right as well. And so what we found when we used those areas of interest that I showed you before is that, first of all, as the graphics became more integrated into the world, there was actually decreased hazard scanning. And so basically with this like basic right in front of you, least realistic head-up display that was screen fixed, that resulted in the most time spent looking at both on and off HUD hazards. And so this is interesting because basically that like simple display, they're doing the most hazard scanning, which we want. Like that's a good thing. And so that's a little bit counterintuitive because I think sometimes there's this assumption that if we can make it more realistic or more lifelike, there's benefits to that. But in this instance, there may not be. We also looked at what percentage of glance time they were focused on the graphic specifically. So that's that HUD graphic only. And you can see like drastic increases as we go from screen to world registered. And so, so again, there's another, that's another thing. We want that number to be lower. We don't want them to fixate on this graphic because we do want them to be scanning. And so we're seeing that, that as it gets more and more integrated into the world, that's not necessarily what we want. I'm including these because they're a little noisy, it's a little messy and maybe hard to parse, because I think that around HUD graphic is some noise. But basically they were focused around the graphic a lot with the screen fixed, but also with world animated 1 and 2. So world fixed, there was a little less focus on it. And then there was about equal amounts of like other things that were either glances within the car or at their watch or other, at their phone, other places that weren't related to the driving task. So there wasn't really a difference between those. But I think the key takeaway here is that, graphic integration doesn't necessarily help drivers. And what we're seeing is that there seems to be an impact of both the spatial location and also the associated motion. And so we just need to be thinking like, it's kind of like, okay, well, we know that the location on the windshield matters, and now we think that these matter as well. And so that begins to get tricky because now we have a lot of parameters to consider. So, so we also considered the driving behaviors to see if there was an impact on the driving behavior or their ability to actually make the turn. So that was kind of added into this. Did they follow the navigation instructions correctly? And we found no differences. So I will not bore you with lots of graphs that have no significant results. But I do think it's important to note why. And so my theory is that, first of all, it was a navigation task. So we couldn't do a lot of trials because basically it would make people sick. So this was my only study where I did have a participant get simulator sickness, and I did have to be on cleanup duty. So that was not fun. So I wouldn't want to extend this study. And that was in part because there were so many turns, and while maintaining the realism of the experience, we couldn't just cut out the turns. We actually still had to have them do it, but that was a lot for people to handle. I think a secondary reason that we may not have seen differences is because of the analysis period. And so we had 4 fundamentally different graphic types, but what we did was we tried to make sure that the portion of data that we analyzed included the same information. So even though the graphics were inherently different, we believe that they had access to the same amount of information across this analysis period. And so what that period is basically as soon as the navigation graphic appeared, 492 feet before they started the turn, they were able to see the direction of the turn and the distance to the turn using some of the cues from the graphics that we had. And so that gave some kind of information that was roughly equivalent as it could be. And so that's why we considered only that portion of data, because if we wanted to include some of the curve, there would have been different graphic behaviors and there would have been different quantities of information. And so there would have been additional confounds that we might not have been able to account for. So anyways, that's kind of where we landed with this, is that, there's more parameters to consider. We have some evidence that they have an impact, and so we do need to consider them. But also, we don't have a lot that's conclusive besides like, we need to know more. And so, going back to kind of the way I'm thinking about designing novel technology, you do it again, that part you can repeat. So you could repeat number 3 a lot, but I think that the whole point of that then is to consider new tasks or goals and start to generalize. And so this is where I mentioned frameworks earlier in my presentation. I think you can start to figure out what frameworks for thinking about the space are useful, and then applying those frameworks to help you kind of develop better hypotheses and understand, are these differences artifacts of the tasks that we're asking them to do? And what can we generalize? What can we use across all of these different across different contexts or different things. So, so I think that, I should have put some arrows to repeat some steps because you may want to repeat many of them. But I think at the end of the day, it is figuring out, how much of this generalizes beyond just this one particular task, unless that's the only thing you're interested in. But I think when it comes to novel technology, more and more what I realize is that we don't even really know what this is most useful for, because we're designing something. And I think, thinking about virtual reality, there was kind of a, depending on how long you want to argue and exactly where you want to put that starting point, there was kind of a like 30-year-ish, 30 to 40-year runway of research before it started to intersect with more consumer-focused work. So I know there was a lot of military work early on, but there was a lot more time to kind of figure out the basics that mattered and then start implementing. And with augmented reality, I think what's different is we're developing this technology. It does not yet exist. And we're trying to figure out what the right applications are and their best use cases before we even have something that is usable. And there's, public knowledge about it. There's a lot of interest in this space. And so in addition to the research that's happening, we also have a lot of design work that's happening without that loop being closed. So it's still kind of open. And I think, there's pros and cons. I think one thing that's a big pro is that then there's time to kind of influence the direction of the development of the technology. And I think that's where I guess I would say, to me, that's the most exciting part of being in an industry, because I do feel like I have the space to actually, if I can make a good enough case, I may actually be able to change the direction that we take. And but in order to do that, I need to be really confident that it is the right direction. And so that's kind of how I came to this process of, figuring out what's the right problem, then parameterizing it, then figuring out all of the parameters that matter and testing that, and then applying it and seeing if it generalizes. So I guess I'm kind of wrapping up. But I think at the highest level, it's like, what does it all mean? And I think you can take what you want from this. I mean, I think there's some like little nuggets that may be useful for specific use cases. Also, certainly frameworks for thinking about the space are very useful. But at a macro level and kind of from a research perspective, in my opinion, there's a couple things that we just need to know. And the first one is that, as I think all of you know, we often come away with more questions than answers. And I think that's just how it is when it comes to designing technology that's new. We're still figuring it all out, and we're just trying to figure out how to describe the space. But also we're getting into like attention and human information processing, which we kind of understand, but actually like there's a lot of mixed research on that as well. And so now we're trying to add more richness, add more information to a space that's so complicated that we don't even fully understand it. So we have a lot more questions than answers. And I think just that's okay. That's an expectation. And as a researcher, to me, that's super exciting because that means there's always more to do. But the other thing that I've seen a lot is that the user's experience doesn't always match the data. And so this is where I talked you through these studies. But what was really interesting to me is that even though I have indications from prior work that traditional head down displays in cars are better in some ways in terms of driving behaviors, only one participant of the few hundred that I've worked with has ever actually said that they prefer that display. And so I'm seeing this difference between what participants believe and then what we're seeing in the data. Or it could be, some of this stuff where they actually had different driving behaviors and they were unaware of that. And so I think that it's just important to kind of keep in mind that, as we're trying to figure out this space, as we're scoping this space, users are also kind of not always reliable, but also extremely important to understand because their experience matters especially depending on like what our goals are with the technology. But it's not the only thing that we need to consider because it depends on kind of what you're optimizing for. So those are the two things that I kind of have sat with as a result of these parts of the work. And that's all I have. So thanks for your time and attention, because as I study them, I know they're limited and often pulled in different directions. So that's all that I have.
Amazing. Thank you so much. This is really good. I like the framework that you use to parameterize the space and then try to test it and then repeat it again. I think it can be applied in multiple research. I'm going to open the opportunity for questions. If you have any questions, please either say them now or you can leave them in the text. I have a question from Ben. Would you like to ask your question, Ben?
Sure. Thanks for that. That was great, Missy. Really interesting area. I probably just assumed that this would already be a thing with heads-up displays in cars, but what I'm interested in is sort of around the legal issues, and in industry, do you have to think about, or what happens if my maps, if it's not accurate, or are you just focusing on the specifics of the technology for now? And the second part is to do with sort of self-driving, because there seems to be the data could be used for both. So do you see that ultimately as being the same thing in the software?
Yeah. So I think the first part is that like absolutely people are thinking about that. I think this is where my kind of the way I think about it now is at least that like depending on where in the life cycle you are, that indicates or dictates how much of your time is focused on like legal specific issues or and so the group that I'm in is very, very early in the research process. And so it's kind of like proof of concept, proof of life. Does this do anything? Does this change anything? And the particular questions I'm interested in are those that are fundamental questions. And I think at the end of the day, we need to understand those first before we understand the implications from a legal perspective. And so I feel like the answer is kind of yes and no. I'm not talking to lawyers on a daily basis, but I am trying to understand because I think we need to know at the most like basic level what are the implications of the technology so that we can make sure we're implementing it in a way that's safe and valuable and useful and desirable. And so, okay, what was the second part of your question?
Just on self-driving cars and sort of the use of AR in that, like, is it redundant or do you see it as being connected?
Yeah, so I think that there's some connection, and I have very strong opinions about self-driving cars, and this is because I spent time in the auto industry and also because I had to answer questions like this a lot of like, does this even matter? We'll have self-driving cars. Can't you just use them? And I think that there's similar questions. I also think that we're very far away from having self-driving cars that are usable by most people. I think that we're going to have normal cars on the road for a very long time. But I do think that there's some similarities in especially thinking about like the extent of world knowledge, because self-driving cars, they need to have extremely high world knowledge. They need to know exactly what's in front of you and what are the implications of hitting it, and is it moving, and what is it? And I think where we've seen problems with self-driving cars, that to me is kind of like their world knowledge was wrong. And so I think that maybe we're using similar types of information, but for different outputs. So I think there's definitely connection. I think it's just like kind of depending on the specific iteration of what are you doing with that augmented reality? Is it for navigation, or, there's some things where it may have no overlap, but I do think that some data sets, some sensors and information could be overlapping. And certainly in a car, if it is sensing all those objects, maybe it wouldn't be a bad idea for it to actually highlight those objects, although maybe it would be. I haven't researched that. I could argue both ways on that, but yeah, definitely
Awesome,
related
thanks.
is the short answer.
Yep, great, thanks.
Yeah, definitely interesting questions about self-driving cars and when the driver need to take over, and whether AR display would help in this area. I had a question at the beginning. You mentioned you are more interested in the left side of the continuum where it's close to reality. And I was wondering if there's something in particular that you are made you interested in that area, or do you believe the world should be more real than virtual? And at what point, I guess, from your examining the continuum or the new continuum you come up with to move to more virtual, I guess?
Yeah, I think it's just like, that's just kind of where I snap to, because it gets to this really interesting question of like layering information. And I think I always put it further on the left side, just because I don't think we usually want to layer that much information. So people, we're constantly taking in information across all of our senses. We're processing that, we're integrating it, and we're making meaning of it. And so I think one of the things that we know to be true, but it's hard to figure out, is that like we don't want to send a ton of information to people now that's digital, because processing the real world is like hard sometimes. There's a lot of information out there and our brain filters out a lot. So I think that we should be kind of parsimonious with how we do that. and make sure that we're not putting too much information when we're integrating. And so I guess to answer that, I would say I'm interested in that integration of layers, because I think understanding like how adding new information changes the way that we're interacting and behaving in the world is incredibly an interesting question. But I also think that we don't want to add too much information because we'll overwhelm people. So I just kind of tend to put it more towards the left than middle.
I understand. I see. We have a question from Rico.
Yeah, thank you. And thank you for a great talk first. And I'm very curious about in their experiment, did you get some feedback from the participants which you didn't expect it, or yeah, some things, new feedbacks from them?
Yeah, I think the most interesting thing is that, you know, I would see people having like what I would describe as really dangerous glance behaviors. And they would, you know, they would just stare at the display and nothing else. And they would be like, oh, I was so much safer. I drove so much better with this head-up display. And so I just saw this conflict. And that's why I mentioned it at the end, because I did see this, like, what they believed was happening didn't really reflect what was happening, at least by the measures that we have. And so I just thought that was incredibly interesting and something that really hooked me, because I think when it comes to science, I'm most interested in being surprised. That was just like a moment of like, wow, we have no idea what's going on. Our brain is just tricking us. And I think that's a fascinating and an exciting place to work. And also an important one, because then we don't know what people are necessarily, you know, when they're right and wrong. So we really need to deeply understand it.
Mm-hmm. Thanks. Yeah, it's very interesting. Yeah.
Thank you. A follow-up question for this. What was like, would participant, did they learn that their observation or their preference or behavior is different to what the data observed? What was their reaction, I guess? Or have they ever?
Yeah, so for these studies, they wouldn't have known, because it took there was enough time between it to basically, like, I could look at their data and see that and be like, wow, this person was totally wrong. But in real time, they didn't know. But I did do a study and it is published. It's like a work in progress from the Auto UI conference, the Automotive User Interfaces conference. And we basically did a really similar study to that first one that I showed you. But in the last condition, we basically like had them do a bunch of boring conditions. And then at the very end, we added on a condition where we were like, oh, we need to collect this data again. And then they actually, instead of doing what was supposed to happen, where it's just a normal drive, the car ahead of them, the car they were following, slammed on the brakes. So we made sure that it was in the middle of a task. So they were actively, you know, doing these tasks. And then this car just slammed on the brakes and they had to respond in some way. And so what was interesting there is, first of all, that people using a head down display, so a traditional display, like it wasn't, I think we had, you know, 10 data points. So it wasn't statistically significant, but it looked like they actually might have performed better. I think if we had a bigger sample size, we might have found it that a head down display actually was, for that type of accident, it was safer or resulted in fewer accidents. And I think that's because people realized kind of subconsciously that they weren't getting information from the road. So they had these conscious glances back to the road, which is consistent with other work that I've done. But my favorite participant ever, and I wish that I could share it, but I don't have the proper permissions, but he was driving and he had it and it was in the middle. So the display was right overlaid onto the car. You could see his eyes back and forth. You could see the car taillights come on as it slammed on the brakes, and he just slammed straight into the car. And then he said, oh, I was not paying attention to that. And it was just the most perfect participant response ever, because he, you know, in the moment it was like, wow, I didn't even see that. And it was right in front of me. And so I think that was a really interesting, that was just a cool video. I wish I could share. But that's my favorite participant, because I was like, yes, you're just getting to the core of it for me on camera.
That's amazing. Yeah, and he acknowledged that. That's great.
Yeah.
I have a question from Amit. Would you like to ask them?
Yes. Yeah. So thanks for the talk, Missy. I guess my first question is, have you looked at, or do you have plans of looking at how using eye tracking to sort of maybe unpack some of these behaviors that you're seeing? Because my research didn't get to the point where I actually wanted to do this. So my research has been more focused on the spatialized auditory side of things. Have you looked at if eye tracking can sort of unpack any of these things when it comes to essentially the driving task is basically a divided attention task where we're looking at the near field, we're looking at the far field and trying to sort of, so that is the first question. And I guess the second question is, have you or are you planning to use binaurally spatialized auditory feedback to sort of support what essentially seems to be a overtly visual way of providing information?
Yeah. So one of the things there's, a lot of clear evidence that virtual reality, or that virtual reality side of the spectrum of the continuum tends to have much worse depth perception issues. Augmented reality, or that left side of the continuum, still has issues relative to real objects, in which there's actually people are perceiving depth differently. And so to shortly answer your question, we didn't use that because we actually depth matched. And so basically it was like, what if the depth of this display is perfectly matched to where you're looking in the world? And because we had that virtual reality display, or the virtual reality driving simulator, we knew that the virtual reality simulator was about 2 to 3 meters in front of the participant. And so we could actually perfectly match it. And so we knew that the display was also focused at the exact same distance. So for driving, because we know there's a cost when depth perception is kind of off, we were trying to mitigate that and basically say, in a best case scenario, does this, do we still have these issues, or do they magically go away and maybe it's just an artifact of depth perception? And so all that to say, for this particular type of task and for these kinds of activities where we are trying to perfectly depth match, we can't do it because the depths match. But I do think that that's a good use for other potential use cases. It's just that there will be lost data when the depths match, or when they're very, very close, because I don't think that we have I don't think it's quite sensitive enough to really distinguish between things that are very, very close in depth. So I've considered it for future work that I didn't do, but also I mean, I think it depends on what you solve for, because we were trying to remove any depth issues. And also you mentioned the spatialized auditory feedback. So I'm not currently working in driving specifically, but I could say that, we're considering a lot of different types of feedback, because I do think that that's an important thing to consider. And I think that there's been a heavy visual focus for a very long time in the field, but also, we have other technology now. We have, that's part of, as we were updating this continuum, part of what facilitated that is that we realized that the existing framework that they had developed was not, or the existing taxonomy, it was really focused on visual, but we are using spatialized audio, or we do have that capability, and that's something that could be studied. We are considering haptics now. It's not all about pixels and graphics and things like that. So I do think that that's something that going forward is definitely very valuable. And there is a lot of research. I think I've seen less research. I guess I see a lot more research that's I'm going to focus on visual and solve that problem, or I'm going to focus on audio and solve that problem, or maybe a couple of mixtures. But I haven't seen a lot of broad work in that space where it's kind of considering the whole spectrum, or the whole kind of wealth of places that we could incorporate information. So anyways, I think that there's a lot of work to be done in that, with considering multiple modalities, particularly simultaneously.
Okay, thanks.
Thank you, Amin. I guess follow up from this as well, since we are talking about multiple modality, you said at the beginning when you're trying to identify the problem to solve, which distracted driver, and one of them was the cognitive distraction, I guess. I was wondering if, and also part of our work here in the lab, we use EEG and try to understand emotion and other sensors, I guess, to the brain. I was wondering if you have, or if you would use EEG or any kind of brain scanning, hyperscanning technology during a driving simulator, what would you expect, or do you think this will add anything to this kind of research or future research?
I think it's tricky because I think you can learn a lot from that. I also think that physiological signals are really noisy, and so you might pick up some other noise, or I guess so. Also, I should say I have not collected any EEG, so I'm not as familiar with that. But I think it's one of those things where it's like figuring out that cost versus benefit of adding that technology. And so for me, with the work that I've done, I don't have that skill set, and I haven't partnered with the right people for that or found the right use case. But I certainly think that, solving for things, being able to understand cognitive distraction is something that's absolutely critical. And I think that what I'm seeing is that when we start to do depth matching, we have problems with figuring out visual distraction, because now it's harder to tell if they're looking at the world or the display. We have some ways we can do that, either by depth, but if they're matched, you could also look at the scan pattern depending on the task that you have. So that might give information. But if you don't have a task that has like a distinct scan pattern or distinct location, then it gets really difficult. And so I think that that's when we're going to have to not rely on visual information to understand what's happening or what kind of distraction. Because if you can't, I mean, at the end of the day, if it's not visual distraction, if it is just purely cognitive distraction, we're not, besides asking subjectively, we haven't, I'm not asking that, I'm not answering that question. And so I definitely think there's value, but I also know that is incredibly difficult to do. So I'm glad that y'all are doing a lot of it and that I don't have to.
Yeah, it's difficult, and I was interested to see if maybe perhaps it will tell me a little bit more about the user experience and behavior versus the data difference. But this is probably something for the future.
Yeah, I think there's a lot of things to do in the future.
Any other questions from? I see a few things here. Can you go back quickly to the slide that shows breakdown of 3 continuum?
Oh, yeah. So I had a question. I guess it's more of the semantics of it, or what you want to convey. So with just the last one that mentions coherence, I was just wondering how the term coherence is being used, or what it's sort of trying to convey, because it goes from no virtual content to every behavior is entirely possible. So what is the function of coherence in that, I guess? Like, does it mean that no virtual content means there's less coherence, or there's more coherence in the world, versus every behavior then entirely plausible then makes it completely incoherent in terms of something that you're viewing or whatever in the world?
Yeah, so I'll answer this, and Rick can also jump in if he is around and wants to. But first thing I should say is that I thought about doing this, but I ran out of time. There should be a breakpoint. So on immersion and coherence, there should be a breakpoint from no virtual content right before no virtual content. And that's because basically, like, it's either fully real or there's some amount of digital. So it's not like it like ramps up, but there is actually like the no virtual content piece is kind of like a point that's separate from the rest. So that's something that should be in there. There actually should be a discontinuity in those continuums. But then to kind of answer your question, it's that as the plausibility of what's being conveyed via that system increases, it means that like basically like that coherence is where I'm using it to indicate like people are, it makes sense to them, is kind of how I think about it. And so it's not that I don't know that believable is quite the right word, because it doesn't necessarily mean that the behaviors are realistic. And so that's something I want to be really clear about, is it's not moving towards like plausible doesn't equal realistic. It's just that like it seems right for the context of that particular digital information or virtual environment that the person is in. And so as it becomes more and more coherent, it's that like it's better and better. So it doesn't necessarily mean that there's more information or that it's more digital, but it just means that it's like performing really well. And so I kind of think like extent of world knowledge is kind of almost like what are we sensing? What are we taking in? What information the system, so that was a bad use. But what information is the system taking in? And immersion is kind of, what is it giving? What information is it giving to people? And then I kind of think about coherence, and this is like, doesn't necessarily always hold up, but it's almost like, what is the software that's running the system and like picking the behaviors? What are the physics? Do those make sense to the person at that point in time? Is kind of how I think about it.
Okay.
Does that help?
Yeah, I guess. I suppose reading the paper will help a little more.
It's certainly better worded.
Yeah,
So,
cool. Thank you so much.
That's great. And thank you for Rick also for being here as well. I have a follow-up question about this, the dimensions that you have here, and you have them as 3. I was wondering if you had more dimension and then you compressed them into 3, or if you had a 4th or 5th dimensions that can be added to this.
yeah, that's a really good question. And I think we started, so the process that we had was, at least by my recollection, is that, we read the paper and it was like, wow, we should probably be using this. And so then the conversation was like, why are we not using this taxonomy? And so instead of like, we didn't begin that conversation with thinking that we were going to change the taxonomy. We actually began that conversation. At least I was panicking because we were going to write a paper about something. And I was like, they have already done it. What are we going to do? And so what we started to do is just to see, like, this is a good taxonomy, but then we started to realize that it didn't quite hold up as things are changing, as the technology has changed. And so it was like, we kind of started just to be like, at least from my perspective, it was more, can we use this? And then what parts of this can we use? And then we kind of realized, so I don't think we ever got past 3. I think we realized that 2 of theirs collapsed into immersion. And then we thought extended world knowledge made perfect sense to stay as it was, but we realized that something was still missing. And that's where plausibility came into play and coherence. And so, so I think if anything, we kind of started with their 3, narrowed it to 2, and then realized that we still needed to add something back, because we needed to capture that, what's happening in the system piece of it. That's not necessarily the output from the system or the input that the system is taking in, but it's really kind of the in the middle point.
Sounds good. Thank you. Anyone else has any other questions or observation? There's a lot of things that we can apply on different kind of research that especially we are doing here as well. And I definitely learned a lot from this talk. I would like to thank you again, Missie, for joining us and for sharing your thoughts and experience with us. If there is any future plans for you to travel to New Zealand, would love to host you here, or Australia. And yeah, thank you very much for all being here as well.
Yeah, thanks for inviting me. This was a lot of fun and really, really good questions and interesting ones. So thanks for those.
Very good.
Thank you.
Thank you, everyone.
All right, bye.
Bye.